This problem involves a dependent equilibria. We have two simultaneous reactions going on. We can recognize it because we're given equilibrium constant for two different processes. This here is our target equation. We want to somehow manipulate the chemical equations associated with each of these equilibrium constants somehow such that they yield this target equation when they're added together. We're going to start by writing out the chemical equation associated with each of these equilibrium constants. Okay, we see that we want to, in our target equation, we want 1 mole of cadmium cyanide. We already have 1 mole of cadmium cyanide in our first reaction, our KSP reaction, so we're going to keep this reaction the same. If we look at our target equation again, we see we want 2 moles of H plus in the reactants. Our second equation has 1 mole of H plus in the products. So we want to reverse this reaction and multiply each coefficient by a factor of 2. Our first equation didn't have anything done to it, so its value of K is unchanged. The K is equal to KSP. Our second equation, remember we reversed, and we've also multiplied each of these coefficients by a factor of 2. So we have to take the reciprocal, but we also have to take the reciprocal of the square, because this is essentially Ka to the minus 2 power. We take the reciprocal because we reversed the direction, but we also have to take into account the fact that we have multiplied all our coefficients by 2. So this is the value of K associated with this reaction. This is the value of K associated with the second reaction. We're going to add these two equations together to get our net equation. Everything on the reactant side stays on the reactant side. Products stay on the product side. However, we're going to make things a little bit easier on ourselves by noticing that the 2 cyanide ions are produced and then immediately consumed. Since we're adding these two reactions together to get a net equation, the value of K associated with the net equation is going to be equal to the product of this K with this K. So now we have our final answer. We note that we only have 1 sig fig here, so we can only use 1 sig fig in our answer.